Hello, this is a video on how to build a FEMA approved do-it-yourself safe room. As always, we have to have a disclaimer. If you follow this and get killed, well, don't come crying to me. FEMA does provide plans for building a safe room using just plywood, 14 gauge steel, and other common materials. And you can pause and look at this website. The reason we built this is because we live in the red zone, zone 4, a very dangerous tornadic area. For us, we wanted to put it in our garage. Decided to put it in this corner. Had to move a few things out of the way. Had to get rid of the tool shelf. And upon mocking it up, found that we had an electrical outlet that was powering our freezer. It was in the way. So the first thing I had to do was move the outlet over a few feet. As you can see, that was pretty easy. Put a plate where the old outlet was and set up the new outlet. That gave us plenty of room. This storm shelter was going to be 4 by 4 by 6 feet high. First thing I did was mock it up, and starting with the sill plate, measured out the studs. The sill plate and the double studs are all glued together with different types of mastic. Once I had that set up, I marked my holes for the anchor. I went with 5.5 inch Home Depot redhead wedge anchors, very solid. For the first, what I call the back wall, I went ahead and I drilled all the holes and I set the anchors. The only problem with that is I had to lift this heavy wall and get them all centered on top of the anchor bolts. I only did that with the back wall and decided that was too much. But building the back wall, I mocked up the double studs. As you can see here, the sill plate and the top plate are treated lumber with regular standard and better in the middle. I went with 6-inch screws as well as adhesive. Here you see the adhesive for the double studs. These were glued and screwed together. I pre-drilled and pre-installed the screws into the sill plate. And then I used adhesive on the ends of the studs. This is what anybody would do. Maybe a little overkill, but can't be too safe. I also pre-drilled the holes for the anchor bolts through the sill plate. Once I had the framework put together, it was time to start with the sandwich of the walls. Putting down adhesive, I laid down the 14 gauge steel sheet. It's 4 foot by 6 foot. Once that was in, then I put some weight on it to have it adhere. The next layer is your 3/4 inch plywood. You lay one piece down horizontally, and then you flip the second or the outer layer 90 degrees so that the grain runs vertically. With that, you want to attach it through the steel into the stud with screws. I used fender washers. This is basically your protection. 2 layers of 90-degree plywood, 14 gauge steel. With that wall put together, it was time to put it on the anchor bolts. I used mastic or adhesive. After that was secured, then I started building the side walls, same as the back wall. Glued, screwed, compression. Rather than build it the way I did the first wall, I built it kind of in place with adhesive on the steel. Then I added the first layer of plywood running vertically, and then applied the second layer horizontally. The next step is to put down your adhesive on the slab, put your wall in place, then drill your holes for your anchor. Much easier than trying to put the whole wall on top of the anchor bolts. Clean that up. And they suggest you use an anchor epoxy. I found this at Home Depot. Seems to work really well. Just hook up the nozzle, squeeze in, pound your anchor bolts down into it, and tighten them up. This is what it looked like, back wall and two side walls. Another view of it, you can see the anchor bolts. The studs are pretty close together, so there's a lot of support. Next, it was time to build the front wall, or the door frame. And here you see it. I've got 3 hinges on the door, and you can see the horizontal double stud cross members to support it. The frame was in place, the metal was attached, and as you look at the door frame, it's double studded up to the door, and then the sill plate, the treated, is just a single piece. When that was set, the interior plywood was applied. On top of that, at 90 degrees vertical, was the outer piece of plywood, all screwed in through the metal. After that, the studs and the sill plate were joined together with these straps. They recommend that all around, at least on each section of your studs. Here's another view looking down. It's a small space, but it's adequate for what we had in mind. Next, it was time to actually put the door in place. The frame was put together, the metal, and from the inside, this is looking out, from the inside it was screwed into place just temporarily. In that position, I could install the inner plywood running horizontally, and then the outer layer of plywood. For the hinges, I had to chop out a section so that the hinge would fit. These were commercial hinges with ball bearings, very heavy duty. They work great. As I said, 3 hinges on the door. The door roughed in, seemed to work fine, open and close. It's basically just like the wall, same structure. Next, it was time to work on the ceiling. The ceiling is going to be made out of concrete. Here's the framework that goes on top of the ceiling. Here it's in position. To add support to the structure, there were rebar at each corner running up from the anchor bolt and up through into the ceiling. I decided to go ahead and weld rebar to the top of the anchor bolts. Here you can see what that looked like. It might be overkill, but as I said before, better safe than sorry. So on each side of each corner, you've got rebar running up all the way up to the top of the ceiling. I also installed a 7-amp battery and a camping LED light. Also wanted to put an air an air vent in there. I had a 2-inch piece of steel pipe. I cut it and welded it together to create the basic frame. Cut a hole in the ceiling, put a temporary brace there, and installed the pipe into it. Around this pipe, I caulked everything, and where the rebar comes up through the stud, the plate, it was caulked as well, so the cement wouldn't drop down. And then whatever rebar I had left, I just put it into, as you can see, kind of a random pattern. What I intended to use was Quikrete. I found this Quikrete 5000. It's a little more heavy-duty concrete. It sets up faster and it's stronger. You mix it until you get a nice, if you've ever worked with concrete, you know what to do, but till there's a nice plastic-like texture. I also put a couple of 2x4s temporary up to hold the ceiling. I didn't think I really needed them, but hey, you never know. So bucket by bucket, concrete was brought up to this area, dumped in, smoothed out. Didn't take very long. I think it took, for this 4x4 area, it took 8 bags of concrete. And I had to put in the date. You gotta know when something was built. I always like to see that. Didn't take long. The water wicked out of it, set up. Of course, concrete takes a while to cure completely. I also decided to put concrete down in between all the studs. So I put these pieces of plywood. They're about 14 inches high, more or less. And I mixed up the same Quikrete 5000 and filled them up to the top of these forms. Just a little more security. This concrete in between the studs may not add a lot of weight, but it certainly solidifies the rebar. Next, it was time to figure out a lock. Up at the top, I've got a bar that runs through a 3/4 inch pipe into another 3/4 inch pipe. That seemed to do an effective job, but I wanted a little bit more. I also have a latch. This bar that I used, it's bent at 90 degrees on the outside and the inside. I also put a pin down at the bottom, and that goes 4 inches into the concrete slab. So you've got the upper lock, the bottom pin, and then you've got the latch. Doesn't do much really, but it's there. Here's a look at the door with trim around it just to seal the cracks. I went ahead and painted this unit white just to kind of camouflage it. Let it blend into the garage a little bit. Here's a shot. You can see the latch that is 90 degrees. That secures the door. It keeps our grandkids from getting in there. I covered it with pegboard. It's very useful. So this is my FEMA approved DIY shelter. The shelter was built for my wife, myself, our grandkids. It's 4x4 by 6 feet high. It was built for less than $1,000. That's mainly what I wanted. Something that was economical, but certainly effective. The steel I found from a local shop. They cut it to length and width, and I would suggest you look locally, see if you can find somebody in your area. The rest of the material you won't have any problem finding at Home Depot or Lowe's, someplace like that. So if you're interested, I hope you have success and safeguard your family. Thanks for watching.